Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Attention car shoppers. Right now at South Carolina Federal Credit Union, you can get a new or used auto loan and pay nothing until 2024, and no payments for 90 days means nothing out of pocket going into the new year. Plus, we have flexible rates and terms, so you could make the best financial choice for you. Learn more at scfederal.org/auto loans. That's scfederal.org/auto loans. Certain restrictions apply. Existing South Carolina Federal credit loans are excluded.
This is SpaceTime Series 26, Episode 62, for broadcast on the 24th of May 2023. Coming up on SpaceTime, Saturn gets 62 new moons, discovery of a wild Martian river on the red planet, and astronomers develop a better way of finding black holes. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered another 62 moons orbiting the ringed world of Saturn. The work catapults the Saturnian system back into first place as the planet with the most number of known moons, now totaling 145. That compares to Jupiter, which has 95 known moons. Over the past 2 decades, Saturn's surroundings have been repeatedly examined for tiny moons with increasing sensitivity. The latest study used a technique known as shift and stack in order to find fainter and thus smaller Saturnian moons. The same method's been used before to search for moons around Neptune and Uranus, but never before for Saturn. It works by shifting a set of sequential images at the rate at which the moon's moving across the sky. The results enhance the moon's signal when all the data's combined and stacked together, allowing moons that were simply too faint to be seen in individual images to become visible in the stacked image. The images were taken using the Canada-France-Hawaii telescope atop of Mauna Kea in Hawaii between 2019 and 2021. By shifting and stacking many sequential images taken during 3-hour spans, astronomers were able to detect moons around Saturn down to just 2.5 kilometers in diameter. Not bad when they're quite literally billions of kilometers away. The original discoveries were made in 2019, uncovering the moons in a meticulous search of the deep imaging acquired that year. But just finding an object close to Saturn in the sky doesn't necessarily mean it's a moon. It could simply be a passing asteroid. To be absolutely sure, the objects need to be tracked for several years in order to be certain that they are really orbiting the planet. After painstakingly matching objects detected on different nights over 2 years, the authors managed to track down 63 objects, thus confirming them as new moons. Now, one of these new moons, designated S2019-S1, was announced back in 2021, with the rest being announced over the last couple of weeks. Now, all of these new moons belong to a class known as irregular moons. These are thought to have initially been captured by Saturn from their original host planet long ago. Compared to regular moons, irregular moons are characterized by their large elliptical and inclined orbits. The number of known Saturnian irregular moons has now doubled to 121, with 58 previously known before the search began. Now, irregular moons tend to clump together in orbital groups based on the tilt of their orbits. In the Saturnian system, there are 3 such groups, whose names are drawn from different mythologies. There's the Inuit group, the Gaelic group, and the much more populated Norse group. And all the new moons fall into one of these 3 known categories, with the Norse group again being the most populated among the new moons. These 3 groups are thought to be the result of collisions, where the current moons in the group are remnants of one or more earlier collisions involving the originally captured moons. The authors have suggested that the large number of small moons in retrograde orbits is the result of a relatively recent, at least in astronomical terms, but really sometime over the last 100 million years or so, a fairly recent disruption of a moderately sized irregular moon that's now been broken down into many fragments that are all catalogued in the Norse group. This is SpaceTime. Still to come, discovery of a wild Martian river on the red planet. And astronomers just got a better way of finding black holes. All that and more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
New evidence discovered in rocks is leading scientists to rethink what water environments looked like on ancient Mars. The new images taken by NASA's Mars Perseverance rover show signs of what was once a wild river raging across the Martian landscape, a river that was deeper and faster moving than scientists had ever seen evidence for on the red planet in the past. This river was part of a network of waterways that flowed into Jezero Crater, the area the six-wheel car-sized rover's been exploring since landing on the red planet more than 2 years ago. Understanding these water environments could help scientists in their efforts to seek out signs of ancient microbial life that may have been preserved in the Martian rock. Perseverance is exploring the top layer of a fan-shaped pile of sedimentary rock that stands about 250 metres tall and features curving layers suggestive of flowing water. It's a geologically fossilised ancient river delta. One question scientists need an answer to is whether the water in this river flowed in relatively shallow streams closer to what NASA's Curiosity rover has found evidence for in Gale Crater, or whether this was a more powerful river system. Stitched together from hundreds of images captured by Perseverance's Mastcam-Z instrument, the two new mosaics created by NASA tend to suggest the latter, revealing coarse river sediment, grains and cobbles. Libby Ives from NASA's Jet Propulsion Laboratory in Pasadena, California, says these indicate a high-energy river that's moving swiftly and transporting lots of sediment and debris downstream. The more powerful the flow of the water, the more easily it can move large pieces of material. Ives, who has a background in studying Earth rivers, has spent the last 6 months analysing images of Martian rivers on the red planet's surface. Years ago, scientists noticed a series of curving bands of layered rock within Jezero Crater, which they dubbed the curvilinear unit. They could clearly see these layers from space, but they're only now able to see them up close thanks to Perseverance. One location within the curvilinear unit, nicknamed Shrinkle Haven, is likely to have been formed by powerfully flowing water. But Mastcam-Z's detailed images have left scientists debating exactly what kind of flow we're talking about. Are we talking about a big river like the Mississippi, which winds and snakes its way across the landscape? Or are we talking about braided rivers like Nebraska's Plate, which form small islands of sedimentary sandbars? When viewed from the ground, the curved layers appear arranged in rows that ripple out across the landscape. They therefore could be the remnants of riverbanks that shifted over time, or the remnants of sandbars that formed in the river. These layers were very much taller in the past. Scientists suspect that after these piles of sediment turned to rock, they were sandblasted by wind over the eons, and eventually carved down to their present size, the wind acting like a scalpel cutting the tops off these deposits. Now, scientists do see deposits like this on Earth, but they've never been as well exposed as what they are on Mars, because here on Earth, they're of course covered with vegetation, and that hides the layers. A second mosaic captured by Perseverance shows a second location that's also part of the curvilinear unit and is located about 450 metres from Shrinkle Haven. called Pine Stand. It's an isolated hill bearing sedimentary layers that curve skyward, some as high as 20 metres. Scientists think these tall layers may also have been formed by powerful river flows, although they're exploring other explanations as well. Ives says these layers are enormously tall for rivers on Earth, but at the same time the most common way to create these landforms would be a river. The study's authors are continuing to examine Mastcam-Z's images for additional clues. They're also peering below the surface using the ground-penetrating radar instrument on Perseverance called RIMFAX, which is short for Radar Imager for Mars Subsurface Experiment. What they learn from both instruments will contribute to an ever-expanding body of knowledge about Mars's ancient watery past. What's exciting here is that we've entered a new phase of Jezro's history, and it's the first time we're seeing environments like this on Mars. Of course, a key objective of Perseverance's mission on Mars is astrobiology, including the search for signs of ancient microbial life. Scientists believe that if evidence of past life is likely to be found on Mars, places like this ancient river delta is where scientists should be looking. As it traverses the fan, Perseverance will characterize the geology and past climate of Mars, paving the way for human exploration on the red planet. And of course, it's also the first mission to collect and store Mars samples for eventual return to Earth. Subsequent NASA missions, in cooperation with the European Space Agency, will send spacecraft to Mars to collect these sealed samples and then return them to Earth for in-depth analysis. This is SpaceTime. Still to come, astronomers just got a better way of finding black holes. All that and more still to come on SpaceTime. One of the big problems about black holes is not knowing where they are. After all, they're black, and so is the rest of space around them. That makes them really hard to see. It's a bit like sitting next to an invisible bomb, which only appears when it's too late to stop it or move away. But that's the thing about black holes. Their gravity's so strong, nothing, not even light, can escape, and so they only make their presence clear when they start feeding. Then material begins falling into the black hole. And this material releases vast amounts of energy as it's ripped apart at the subatomic level before disappearing beyond the monster's event horizon, a sort of point of no return beyond which escape is impossible. The quiet, invisible black holes remain a problem, but astronomers have now developed a new way of detecting the active ones, those that are feeding, and the new method they've come up with not only points them out, but can also measure how much food they're sucking in. Most, if not all, galaxies are thought to contain supermassive black holes at their centres. But not all supermassive black holes are feeding. Sagittarius A star is the supermassive black hole at the centre of our own galaxy, the Milky Way. It's around 4.3 million times the mass of our Sun, and it's located 27,000 light-years away. And importantly, it appears to be quiet, at least at the moment. Still, massive cone-shaped gamma-ray clouds, known as Fermi bubbles, stretch out tens of thousands of light-years above and below the centre of the galaxy's disk, clear evidence of past meals consumed by Sagittarius A star. The new technique, which the astronomers have come up with, can determine if supermassive black holes are feeding in distant galaxies, and it can be applied to literally millions of galaxies across the sky. Until now, identifying feeding black holes has been challenging, with astronomers having to specifically look for them individually using complex methods unique to individual types of telescopes: radio, optical, X-ray, and gamma ray. Instead, this new technique works on typical telescope observations that already exist for millions of galaxies. One of the study's authors, Sabine Belstedt from the University of Western Australia, node of the International Centre of Radio Astronomy Research, says the new technique allows scientists to search large numbers of galaxies at once and learn about their central black holes.
I'm Dr. Sabine Belstedt. I'm a research associate here at ICRA. Black holes are just one aspect of a galaxy, and they're embedded in the middle, and when you look at a galaxy, it's bright. But you don't necessarily obviously see the black hole because it is black. We've been looking at pictures of galaxies in many different wavelengths of light, and using that then to have some really fancy code that we can model this light and pick where a black hole is. So the type of black hole that we're interested in our work is a supermassive black hole in the middle of a galaxy. It's a very enormous kind of black hole, and in particular, one of the reasons why we're interested in understanding more about them is because they really change the way a galaxy looks to us. We're interested in galaxies because we want to understand how they have evolved and changed with time. If we don't know enough about the supermassive black hole inside them, then everything we learn about galaxies isn't quite right, and so we need to learn that more carefully to learn about how galaxies have changed. The most exciting element about this research is the fact that we can now look at huge samples of galaxies, hundreds of thousands, and even in the future, millions of galaxies. And without having to do anything separately to the analysis we've done before, we can now look at all of these galaxies, and with one fell swoop, we can understand which of them have supermassive black holes in them that are shining brightly, and which of them don't. DEVILS is a survey that has been conducted on the Anglo-Australian telescope in New South Wales, in Australia. We've been using the telescope to collect what is known as a redshift, so a measure of the distance to a galaxy for about 60,000 galaxies in a tiny patch of the sky. These galaxies are, some of them nearby, others they are billions and billions of years in the past, so they're very, very far away. These are the galaxies that we've been analysing in this research to analyse how it is that they've changed and how it is that their supermassive black holes have changed over time. There's currently a telescope in Chile that is undergoing a renovation. That renovation, once complete, will enable new surveys to begin, bigger and better than we've done before. One of those will be the WAVES survey, which is looking at galaxies, about 1.6 million of them. Once we have those data, we will be able to analyse those millions of galaxies in the same way that we're doing with this study, and we'll learn more about them on a scale thus far unknown.
The study's co-author, Jessica Thorne, also from the University of Western Australia's node of the International Centre for Radio Astronomy Research, says the new technique combines multi-bands of electromagnetic wavelengths from a range of telescopes in order to identify which galaxies contain feeding supermassive black holes and which are quiet.
My name is Jess Thorne. I'm a PhD student at ICRA UWA. Black holes are some of the darkest and most elusive objects in the universe. We don't know all that much about what happens inside them, but in the centers of most massive galaxies in the universe, they can be some of the most luminous objects. So they can suck in stuff from around them, and as they do this, the stuff gets heated up and becomes super, super bright. And in some cases, this can outshine the host galaxy of the black hole. Usually we find these active galactic nuclei, these central black holes, by using specialist telescopes like the X-ray or the radio, and using specialist techniques to reduce the data and find these black holes. We've taken a new technique where we can use existing imaging from multiple telescopes, combine it all together using images of the galaxy in multiple wavelengths, and use it to identify which galaxies host these active galactic nuclei. This research is really exciting because generally in the past, to find these active galactic nuclei, we have to point an X-ray telescope at the same patch of sky for millions of seconds, whereas this new research will allow us to combine imaging that already exists and takes much less time to collect. We can piece it all together to find these active galactic nuclei a lot quicker than previous methods. This research excites me a lot because these active galactic nuclei can have a huge impact on their host galaxies. They're sucking in large amount of matter, emitting a large amount of light, and we expect that this will have a huge impact on the host galaxy itself. We think that this might lead to a shutdown of star formation in the galaxy and can potentially kill all star formation in the galaxy. And we can use these to understand what the future of the universe will be like.
That's Jessica Thorne from the University of Western Australia. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has measured the extent to which a bone fracture could lead to early death. And they've created a publicly available tool which doctors and patients can use to calculate the risk. The findings, reported in the journal eLife, examined data from over 1.6 million adults. The authors found that a bone fracture was associated with a loss of 1 to 7 years of life, depending on gender, age, and bone site. This metric has now been incorporated into an online calculator that measures bone fragility in order to help doctors and patients better understand the true gravity of bone fractures. Scientists have developed a genetically modified variety of Cavendish bananas designed to help save the world's Cavendish banana production. The new variety, called QCAV4, has now been submitted for regulatory approval to the federal government. The QCAV4 banana is in fact the first Australian genetically modified fruit, or should that be herb, to be submitted for assessment. If approved, it would offer a potential safety net against the devastating Panama disease tropical race 4, which threatens the world's $20 billion banana industry. QCAV4 bananas have been grown in field trials in the Northern Territory for over 6 years and have proven to be highly resistant to Panama disease. Panama disease has already crippled Cavendish banana production in Asia and has now started to take a foothold in South America. It already occurs in Australia in both the Northern Territory and Northern Queensland. QCAV4 is a Cavendish Grand Nain banana, which has been bioengineered with a single gene, RGA2, from the wild Southeast Asian banana. Mind you, normal Cavendish bananas already contain the same gene, but it lies dormant. And the aim of this exercise has been to develop a variety that gets the gene to do its thing. And that's important because Cavendish bananas account for 97% of all global banana production. Well, it seems artificial intelligence has taken another step towards its eventual Skynet-like takeover of human civilization, with researchers finding that humans tend to be more empathetic towards AIs if they seem to disclose personal information. A report in the journal PLOS ONE showed how researchers instructed participants to have a text-based chat with an online AI and to play out a scenario between two co-workers. In each conversation, the AI appeared to self-disclose either highly work-relevant personal information, less relevant information about a hobby, or no personal information at all. Scientists say that compared with the less relevant sharing or no sharing at all, bots that chatted about themselves and work wound up getting far more empathy from human participants. Meanwhile, after earlier passing its medical licensing exam with 60% accuracy and scoring 297 on its legal bar exam, which would have been enough to be admitted to practice law in most American states, the Chat GPT-4 AI has now successfully passed its radiological board exam. A report in the journal Radiology says Chat GPT-4 managed to exceed the passing threshold with a score of 81%, showcasing significant improvements, especially in higher-order thinking questions. Apple has rolled out its emergency SOS satellite link feature to iPhone 14 users in Australia and New Zealand. The new feature has only been available up to now for devices in North America and Europe. With the details, we're joined by technology editor Alex Zaharov-Reut from techadvice.life.
Yeah, it's the emergency SOS via satellite, and this has now arrived in Australia and New Zealand, and it is exclusive to the 4 iPhone 14 models, the iPhone 14, the Plus, the Pro, and the Pro Max. And it's been only about 8 months. I mean, I was actually in Hawaii at the Qualcomm conference on the day that Apple made the capability available in the US, and I was testing it out there. And when they made it available in Australia, I was able to immediately go outside, hold my phone to the sky, go into the settings, go to the emergency SOS section, scroll down to the bottom and try the emergency SOS via satellite demo, which takes you through a simulated experience. However, it does actually connect you to a real satellite, and you have to hold the phone to the sky. It's asking you to turn left or turn right, and the satellites are moving obviously very quickly overhead. It can take some minutes for the connection, but within a couple of minutes I was connected, and then it is using a series of predetermined questions, and it compresses the text by about 3 times to make sure that the message can be sent as quickly as possible. And already it has saved lives in the 12 countries that it is currently available. So no doubt we will be hearing very soon that it has also saved lives in Australia and New Zealand, because as soon as you're in an area where there's no mobile reception, some people I did note were commenting, I've seen my phone saying no service, but I was still able to get a call through to 000. And that's because Telstra, the biggest carrier in Australia, has 1.2 million square kilometres of additional coverage compared to its competitors. So even if you're on one of the other phone providers or you're on a mobile virtual network operator that operates on Telstra's wholesale network, you may still be in range of Telstra's entire network, in which case the 000 call will go through. But when you're not in any coverage area at all, you're stuffed unless somebody drives by. So it's really a wonderful thing. It only took them 8 months to bring it to the Southern Hemisphere, which is very impressive. And we did have Qualcomm announce at CES in January that they would have a pole-to-pole service that would, Qualcomm satellites that would be available next year, some or later this year. But I'm sure that by the time the Qualcomm service will launch, Apple's will also most likely cover pole-to-pole, and it will signal the new era of being able to connect via satellites just using your phone. And eventually your phone will deliver phone calls and browsing and all the rest. But for the time being,
it's text right now, isn't it?
It's just text, yeah, but it's also the ability for your friends and family to track you with your permission using the Find My service. So if you're in the Blue Mountains in Australia, for example, you're in the outback somewhere and you aren't able to be connected to a Wi-Fi or 3G, 4G or 5G network, then you can still be tracked via satellite, which is quite incredible.
Does this system replace the EPIRB or not really?
They do not replace the EPIRBs, which stand for Emergency Position Indicating Radio Beacons, and they also don't replace traditional satellite phones, which cost about $1,000 to buy. You also have these personal locator beacons as well. I did have a company email me saying, hey, we sell in Australia a brand of personal locator beacons, as we're calling it. They have a 7-year battery life. For the true adventurer, just relying on your iPhone is probably not going to be enough. You're going to want to have more. You're going to want to have a satellite phone, an EPIRB, these locator beacons.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.